In this video, I'm going to work through this problem of taking this rational expression and dividing him by a polynomial. All right? So remember that when we divide, we're going to multiply by the reciprocal. Well, the reciprocal of a polynomial looks like what? Well, remember, if I force this to be a fraction, I can write this over 1. Okay? So now, when I rewrite this as a multiplication problem, and take the reciprocal, it's 1 over this polynomial now. Okay? Well, what does it look like when I multiply two rational expressions? Well, I'm going to factor all of these polynomials first, as much as I can factor them, so factor them completely, and then we'll see if there are any common factors in the numerator and the denominator that will cancel out. Okay, so let's do the 3x squared minus 7x plus 2 first. And I'm just going to rewrite this down here so I have a little bit of room to work. It looks like the 3 will not factor out, so I'll have to use my AC method. So 3 times 2 is 6. Factors of 6, factors of positive 6, that add to negative 7. Well, if they add to a negative and they multiply to a positive, they both have to be the same. And it looks like negative 1 and negative 6 with my ticket. So I'm going to rewrite that linear term as negative x and then minus 6x. And the other two terms just come along for the ride. And now I'm going to do factor by grouping. So an x will make 3x minus 1, and a minus 2 will make 3x minus 1. Okay, so this right here ends up being x minus 2 and 3x minus 1, which is the factorization of this quadratic. So let's go ahead and write that then. So x minus 2, 3x minus 1 over, and then x squared minus x looks like I can take a greatest common factor of x out, and I'll be left with x minus 1. And my multiplication here, well, okay, well, I got to factor this whole thing now. Looks like 4 terms, so it could be that I can use grouping right away. Okay, so I'll kind of make some room here. There we go. So I can pull an x squared out of the first one, and I'll get, what, 3x minus 1, and a negative 4 out of the second one, and get 3x minus 1. Okay, so, x squared minus 4, 3x minus 1. Oh, that's difference of squares, isn't it? So x plus 2, x minus 2, 3x minus 1. So I actually have 3 factors that this will come down to, and that's in the denominator underneath my 1. So 1 on top, and now on bottom I have x plus 2, x minus 2, and 3x minus 1. So let's look at everything together now. What can cancel, remember top to bottom, any common factors from the numerator can cancel with any factor that's in common with the denominator. So x minus 2, x minus 2, 3x minus 1, 3x minus 1, and it looks like nothing else will cancel. So my numerator just looks like everything canceled here, and I just have a 1 on top. And the denominator looks like x times x minus 1 times x plus 2. So we'll go ahead and multiply this through. So let's multiply these two first. So it's x times x squared plus x minus 2. So then ultimately when I distribute this x then through, it's 1 over x cubed plus x squared minus 2x. But let's go ahead and take a look at the values of x that need to be omitted. All right, so I canceled out an x minus 2 top to bottom, so that means x cannot be positive 2 because 2 minus 2 would be 0. 3x minus 1, well, if I look at it this way and say 3x minus 1 cannot be 0, when I add 1 to both sides, 3x can't be 1. and then I'll divide, so x cannot be 1/3. We also have that little trick where we change the sign, numerator, denominator, so positive 1/3. All right. Now, as we've done previously, we need to go back to the original problem and ensure that there's nothing that we needed to have taken into consideration up here. So we were dividing by a polynomial, but a polynomial was not a rational expression. It just had a 1 in the denominator, so there were no, extra values of x that I needed to take into consideration. So it looks like what I have down here should be my final answer. Okay, so here's the quotient, then, when I divide our original rational expression by this polynomial.